Hi, welcome to Wiggum. This is a web-based application for users to explore their dataset, particularly help users to discover Simpson paradox or mixed effects. After installing and running the Wiggum command, you can start Wiggum from your browser. We start from the data annotation and augmentation page. You can load your data by opening a CSV file or upload a previous saved data folder.
Now click Choose File button to select a data file. Then click Open button to load the dataset.
After data opens, you can select variables type, rows, and other properties for each variable in the dataset. The user picked the variables type based on the variable's data type.
Users can choose categorical or continuous data type.
And rows based on what trend the user wants to observe and how the user wants to partition the dataset.
We choose dependent for x1, dependent and independent for x2 and x3. Split by for chart and color.
Once the data labeling is done, you can save the variable settings by clicking the Save button.
We first input the project name, then click the Save button.
Next time, you can directly use the same variable's metadata from the saved data folder. We also provide 3 data augmentation approaches in Wiggum. In this area, users can compute quantiles, cluster the dataset, or add intersections to generate more categorical variables. Now we pick up a trend type, Pearson correlation, and click the Visualize Trends button to the visualization page. In the visualization page, you will see 3 main components. On the left side, a legend for the distance heat maps, and the control panel for interacting with the detected result. In the center, the distance heat map view provides an overview of the instances from the result table. The view consists of multiple distance heat maps. Each distance heat map represents a subgroup partitioned by the categorical variable. The color in the heat map encodes the distance calculated by Wiggum. The dark red encodes a distance 1, which indicates the reverse trend between the aggregate data and the subgroup. The light red encodes a distance 0, representing the same trend. Gray color indicates a not applicable cell. In each distance heat map, the horizontal axis shows the independent variables that are set by the user in the configuration page. The vertical axis shows the dependent variables. In the bottom, a result table view shows the details for each detected instances. Clicking on a cell in the distance heat map pulls up a detailed view. For this one, you can see a scatter plot in the detail view. The x-axis in the scatter plot represents the independent variable x2, and the y-axis represents the dependent variable x1. Since we clicked a dark red cell in the distance heat map, the aggregate trend drawn by a black dashed line shows positive. The selected subgroup trend highlighted in yellow is negative. This will let users know there is a reverse trend. Now let's click a light red cell in the distance heat map. You will see the subgroup trend is positive, and the aggregate trend is positive as well. They are the same trends. Please feel free to ask any questions.